welcome everybody to the AI Data Center Hardware and Software Breakout session. So we've got two of the three speakers. Vamsi is in a one-on-one. We had a conflict, so he'll be running here in about 15 minutes or so. Vamsi can answer any questions you have on software updates, ROCm 6. So if you could hold those software questions till Vamsi arrives, like I said, hopefully about 15 minutes from now. But Andrew and Brad can answer any questions around, our AI strategy, the MI300 A and X you heard about. So with that, we're PowerPoint free here, guys. It's really just anything you need clarification on, anything you heard in the live stream, anything you heard today in the other conversations you're looking for clarification on, any questions you had about the products, the software updates, the partner collaborations, any of that, that's what we're here to do today, to answer those questions for you. So we do have mics, so if you could put your hand up, we'll bring you a mic so you can ask your question.
What kind of chiplet technology for HBM? So CoWoS or for TSMC?
So now let's put the picture up. So the short version of the answer, this is good enough. If this is good enough, we can park here. It's a CoWoS on the base and then SOIC between the IOD and the XCDs and the CCDs. So SOIC there, and then everything else is connected with CoWoS. Does that get you what you're looking for?
Yes.
Okay.
And also, I want to make sure. So you mean, which one is a 6 nanometer, which one is 5 nanometer? So XCD, IOD, and also memories or something.
All right, Alan, correct me if I get it wrong, but 6 nanometer IOD compute elements are 5 nanometer.
Okay. And also, so I think that your IOD is also some of Infinity Fabric and PCI Express. So I think that you have also MI6 300X is a 7 by 16 Infinity Fabric. So however, so MI300A is a 4 by 16 Infinity Fabric and also 4 by 16 PCI Express. What do you mean is your IODs are both support Infinity Fabric and PCI Express?
The short version to answer your question is yes, it does both.
So you have a 4 lane, 4 by 16 each on an IOD.
Correct. Yeah, that's right. I'll let Alan. A certain number of them are ambidextrous and a certain number are...
There's 4 IOD chiplets. Each IOD has 2 by 16 links. One of those links is Infinity Fabric only. One of them is a mixed mode link, PCI Express Gen 5, and Infinity Fabric. So it's a dual personality link. So when you aggregate all of them together, you have 4 by 16 that can have dual personality, and 4 by 16 that are Infinity Fabric only. So in MI300A, in the platform, in the 4P platform, there's 6 links that connect the GPUs together with Infinity Fabric. There's a point-to-point link with 2 by 16 between the 3 other GPUs that each is connected to.
Your MI300X has a support 192 gigabyte HBM memory. However, so A is a 128 gigabyte memory. So what is the differences between the two of memory size?
Yeah, I'll let Brad take that. It's a product choice.
Yeah. So we basically we're using a 12 high stack on X and an 8 high stack on A. It's driven by the workload, our view of the workload that we're primarily targeting into.
It's kind of you depend on the market. So.
Yeah.
Okay. Thank you.
Good.
We use 3.5 packaging. Why we use 3.5?
Oh, yeah. It's a term we try to use to communicate that we had 2.5D and 3D. So we called it 3.5D, because we had the CoWAS underneath the SOIC 3D stack.
Do you have plans to develop and sell version of MI300 that satisfies restrictions on exports of advanced chip technology to China?
So I think Lisa has commented on this question in some recent earnings calls as well. I mean, the Chinese market is an important market for AMD overall. Obviously, it's a huge part of the worldwide economy. We do not have a product announcement in that area to date. So we have nothing to announce today, but we view that as an important market.
Hi. Thank you so much for inviting us, and great presentation and a great event until now. The presentation made with regards to the MI300 and the improvements as comparison with the NVIDIA's H100 specifically shows the improvement that it has made. But this goes on with NVIDIA releasing H200 next year, right? How does that compare? How do you kind of plan to foresee this competition and address it accordingly?
We see it as a very competitive market. It's a very large market. We described it today. It's a very large market, and there will be a lot of focus on it. We expect our competitors to react to our announcement, but we have a very strong roadmap that we look forward to sharing with you guys as the time goes on, and we intend to lead in this market.
Okay, and I think the next, okay, so I'll keep the next question to Vamsi, but I have one more question with regards to the Indian market specifically. I think you opened a design center recently in Bangalore last week, I think. So any future plans for AMD specifically in the context of AI for India?
Any plans to do what?
Any plans for AMD to expand in India?
Well, you just said we announced a design center in there, in India, and so we are expanding there.
Are you asking specifically on AI development in the
Yeah,
region?
specific to AI and
Oh.
the future.
Yeah, okay. Do we have AI development in
Specific to
India?
AI, yeah.
Oh, I'm sorry, yeah. The short version is yes. I think parts of our chip design team are there, parts of our AI team are there. Our software AI team are there.
Fantastic. Thank you so much.
Yeah.
Thank you. MI300 is indeed one of the few products that can challenge H100, but there are also Intel Gaudi 2 and Ceres, etc. So my question is, what are AMD's outstanding advantages in the whole market? Are there any more specific goals you can share today in the field of training and inference today? Thank you.
Sure.
So we talked about this in one of the other presentations. We have, obviously there's other competitors in the market because it's a large market and it draws investment. I think what is AMD doing uniquely to be well positioned to compete, not as a second-class citizen, but as a full-fledged competitor versus the incumbent? I mean, the number one thing that we're doing is our product is easy to adopt, right? So we talked about that in different ways, both from a hardware perspective as well as a software perspective, right? And so if we create a unique architecture that is too difficult to adopt, it will not have success in the market because the market is moving too quickly. So speed of advancement for the developers is very important. Also being easy to adopt for the large cloud service providers and OEMs is critical. And as Lisa described in the main session, our MI300X board is form factor and power footprint compatible with the HGX solution. So that has, I think, Ajit from Meta mentioned, this has been the shortest time from start to production of any AI platform or any server platform that they've worked on in the past. So that's one key differentiator for us, is that we have, right now, generative AI is built upon general purpose GPUs, such as NVIDIA is providing and we're providing. So we're coming to market with a known, tried and tested technology. I'd say the other key differentiator that we have is we're coming to the market with all of the key components required to be competitive. Because it's not just coming to market with an accelerator. Yes, you need an accelerator, this is required. But you also need world-class CPU and networking. AMD has not just, we have the best CPUs, we have extremely competitive, we showed all the advantages of our GPU, and we have world-class networking. We're bringing all those together to provide a complete cluster solution with our partners, right? Because, Forrest talked about in his presentation, it's not just a server, it's, the large AI users are using thousands, tens of thousands of these servers networked together in a large cluster. And so we, AMD, can provide all the foundational building blocks for those large clusters, and we can provide very tight integration along with our partners to provide that solution. And I think the third one is that just the tight partnerships with AMD and our end users, right? We've had many of our leading AI clients come on stage with us today. Those partnerships are very, very deep, and we do a lot of co-development with those partners. So I think, the market definitely needs choice, and I think we have established ourselves as the most logical, easy to adopt alternative choice in the market, which is very competitive. The last point that I'd point out is, we talked about performance, many charts on performance. We are coming to the market with something that is better performance than the current state-of-the-art technology from the incumbent. So we're not comparing against a generation ago, 2 generations ago. Our accelerators, are as performant or more, depending on the workload, with our memory advantages than the highest performing previous solutions available in the market. So I think it's really those 4 things. We're bringing them together and providing that holistically. That's what sets AMD apart from the other people that are also trying to participate in the market.
My question is that I've read that NVIDIA, their processors are between $25,000 and $40,000 US each, and they can be dozens or hundreds of those in various installations. You mentioned that your processors are competitive, which they generally speaking are. Do you have a price that compares with what it costs for an H100 that you can share?
Yeah, of course we have pricing established because we have multiple clients that have come on stage and said that they are committed to using our product. So obviously, as part of that discussion, we've discussed not only the technical merits of our product, they believe that we have something that's very competitive, but yeah, we have commercial terms with our key clients. I would say, the value that these AI processors bring to the market is extremely high. The cost of these devices, these are not cheap devices, and they're costly to manufacture. But AMD is committed to providing, I think, good value for what we're providing to the market, and that's what we're doing. We're partnering very closely. We know that we have to provide some incentive versus the incumbent, but we have a very, very competitive product, and we are providing sufficient incentive for folks to move forward and be excited about adopting our solution.
Do you think the prices come in at lower than that, or around the same ballpark, or you just don't want to say?
I'm not going to comment specifically about our exact pricing,
Sure.
but I will say that I think you've seen from the pretty broad range of users that have indicated publicly now that they're using our product that we have agreed upon a price that we both think is fair.
Great. Well, that's great. Thank you.
HBM seems to be the important components for the memory capacity and bandwidth of MI300. So what I want to ask is that which company would be the main provider of HBM? Since like Samsung and SK Hynix are really competing each other to provide to HBM to NVIDIA and AMD. So which one would be the main vendor or the partnership with AMD?
I mean, Brad, you can correct me, but I don't think we want to talk about a main vendor.
We support them all.
We are working with all of the major HBM vendors, right? So having choice in our supply chain is very important, right? Because we're scaling up pretty large scale manufacturing, right? And we need for supply chain diversity and choice to have multiple vendors qualified, which is in fact what we're doing with MI300. We have multiple vendors that we have engaged on the HBM side.
So you guys are considering multiple vendors for like Samsung, can be the vendor and SK Hynix and Micron, like all those?
That's correct. We're engaged with all of the major HBM vendors with that product.
Okay, good. Thank you.
Yeah.
Sorry, one question from platform, sorry. One question from Taiwan Media, Digitimes. Thank you. So, the COWOS manufacturing process is really, really tight. I mean, the supply is very tight from the TSMC. So we can see that NVIDIA has taken over half of the productivity. And can you please share if AMD can make sure to secure more productivity for the MI300 series to satisfy the request from the big clients, including Microsoft, etc.
So the question is really, do we have sufficient supply? Do we feel confident in being able to manufacture these products and provide at scale? Short answer is yes. AMD, well, that's I guess a fifth major advantage for AMD is we have scale. We are a very significant customer already for TSMC and for the major HBM vendors. So we worked hard for many, many months to secure, we think, a sufficient amount of capacity to scale our manufacturing. And we feel good about our supply chain readiness to support production ramp with these products.
Hi, thank you for taking my questions. So in today's keynote, Lisa talked about the interconnect between the chips. But the volume of the data transmission would definitely increase in the future. So can you share more your future plans about how AMD will develop the interconnect technology? That's my first question. And my second question is, nowadays, like CSP enterprise, like Google or AWS, they develop their own chips, like ASIC chips. So do you think this will have impact on the AMD products? Thank you.
So, the first answer on interconnect, we have two levels of interconnect. We have our on-node interconnect. We talked about that today. We think that's a very important point in the very important IP in the industry. And we announced today that we have taken our on-node interconnect, we call it Infinity Fabric, and we're opening it up. We are continuing in our investment in that, and we think it is a world-class interconnect. We heard today that Broadcom is picking that interconnect up and using it as well. So we actually think that we're going to see that interconnect get a lot of support and a lot of investment and be very competitive. Likewise, there's the node-to-node interconnect between servers. And that interconnect, Forrest talked about quite a bit. We see that as being an industry, and it becoming and evolving to becoming Ethernet. And we are working very closely with our partners, as well as investing there ourselves. We have two recent acquisitions, and both Xilinx, who brought a very strong Ethernet solution, as well as Pensando. So we are going to work with our partners, as we brought on stage, as well as making investments in ourselves for a very strong chip-to-chip or node-to-node interconnect. So we see both of those as very important investments and places we're putting a lot of money. As far as the question of so many of our partners, both Meta and Microsoft, that stood on stage today, both have announced internal chip development too. My best answer to that is refer you back to a $400 billion market. This is an incredibly big market that will be serviced by many designs because it's a diverse market. There's going to be a lot of workloads. So there will be many winners. in this market. So we don't see this as an exclusivity that it'll all go one way or the other, but as there will be a lot of winners in this market, and we expect to fully participate. We talked about, I think it was in this session, we talked about the role of the GPU and how important it is because of its programmability and diversity of workloads that it can address. We think it's going to do very, very well in this very, very large market, and we'll get a very large share of that because as the workload changes, we feel the GPU is very well tuned and able to adjust to the workload very rapidly. So that's what we see as the lay of the land there.
So there's a quick follow-up for the first question. So does AMD develop the Infinity Fabric by yourself, or you have the partners working with you?
The answer is all of the above. We developed the Infinity Fabric many ways. It's not a single thing. We have some partners that participate in it, and in some cases we do it all ourselves. So both.
Thank you. This question is for Audrey. Hi. Thank you so much for making the time. ROCm and CUDA are often compared. You've just released ROCm 6. How do you see this competition faring now between the two? My second question was very similar to the one that I also asked David, Rakesh, and the team there, right? Especially when it comes to the go-to-market strategy, and I'm talking from the context of India because I have seen how it unfolds a little bit more and have a little more context on that. NVIDIA and its products or software are a more household name, and especially that is more relevant in that sense because this is, but CUDA, especially in terms of AI/ML developer community as well, CUDA is more of a household name than ROCm. What's your strategy to kind of compete to that, kind of reach out to more developers, compete with the getting more market share?
Yeah, so again, both are very good questions. I'll take them in order. So if you think about ROCm and the strategy there and CUDA, there's a few big differences. The most important one is I'd like maybe for us to think about how development is happening as we think about AI moving forward. 5, maybe 10 years back, right? People were writing pretty low-level code, and that was the start of libraries, assembly code, and so on and so forth. But as AI has proliferated, AI development has picked up pace, right? Most people want to develop at higher levels, PyTorch and other frameworks and so on. So that actually helps the overall AMD cause because if you're able to provide good environments that take in new code that's being written in frameworks like PyTorch and you're able to compile it automatically, then it's not really a competition with CUDA anymore. It's who actually compiles well and how many models run out of the box, and that's what we've been focused on. And we've said that we're going to be on that journey, and we have now demonstrated. You saw in some of the charts that we have tens of thousands of models that run on a nightly basis. So we've come a long way. So we feel good about that portion of the journey. Now there will always be a little bit of CUDA code at the lowest levels that people have that have been lying around for years. But we are the only platform actually that even has a shot at porting that, right? Because we are the other GPU platform that anybody can do. So from that point of view, yeah, there is a path. It's more painful, but the way forward is people are developing at higher levels. So that's the first answer. And the second answer is, how do we develop sort of momentum, media perspective, ecosystem, and so on, right? Few things, right? The biggest one I would say is, in addition to making the software easy to use, to compile models automatically, those sorts of things, is access to our platforms. So if I was a developer in India and you said, hey, how do I use ROCm, where do I build it? Not that easy to get one because, it's not like there was ready cloud instances. Our consumer cards actually were not supported through ROCm until just in the last couple of months. So we are taking steps to improve access to our platforms. So next year there will be lots of cloud instances where people can go access. You can start programming on our Radeon GPUs, which are very readily available. So using those kind of things, we foster developers to be able to come onto our platforms, and then the software itself is making progress, so that models compile readily. So you combine all that, I think that's why we believe that we are right at the cusp of this inflection.
Thank you so much.
Do you want to mention the developer conference?
Yes. It's a good reminder. We are also doing things like developer contests. So we just announced in the last few days that we launch our AI developer contest, where you can target innovative applications to our GPUs or to our other platforms, Ryzen and so on, and prizes and motivating the community to innovate with all the latest that we provide.
Again through Hackster?
That's through Hackster.
Yeah. Thank you.
Yeah, good reminder.
Okay, so I have another question for software side. So I think also NVIDIA's strongest point in CUDA is also they have a domain-specific, toolkit like for automotive, for robot, and blah blah blah. So could you give me your vision for a domain-specific tool for LoCM in the future?
Yeah. So we have been very focused on ensuring that the most important AI enablements happen, and they're happening well on platform. And what I mean by that is, no matter what toolkit you are for a domain, in the end, you have to compile an AI model onto hardware. And so we have been relentlessly focused on ensuring that any model under the sun is going to compile to our hardware. So you see the results, right, with Hugging Face, with PyTorch. We're basically taking readily available things and compiling to hardware. And our customers, right, are wanting that as the most important priorities. Now, there could be other domain-specific extensions on top of that we could layer on, but that is a journey that we are going to take over time. We are not in a hurry to say, hey, I need to cover all these domains, because the most important thing that customers need, we are focused on delivering that.
Okay. And another question for compared to G200, so I mean Gracehopper, so because MI300A is pretty similar architecture, except their ARM processor. So could you give me your advantage versus to G200?
Yeah, so the primary thing is, if you look at the GH200, it's very similar architecture to our previous generation Frontier, coherent bus between a CPU and a GPU. The main there's a couple. I'll go to two primary differences that advantage the A architecture. One, even if you have a coherent bus between a CPU and a GPU, the data still has to be copied. Okay, the hardware does it automatically for you and keeps a coherent copy, but the data's still moving. That burns power, it increases latency, and it could degrade performance if the copies are exposed. In the A architecture, the data doesn't move. The memory is truly shared. So it does not have to move. It's instantaneous. GPU computes, CPU computes. The OpenFOAM example we gave you does that. The other thing that you get with the A architecture, where the CPU and the GPU are on the same module, is you get very effective power sharing. Because it's all on the same module, you have access to the state of the entire machine real time. Power management software can be very effective in shifting power between the CPU and the GPU, and you get very effective power performance.
So CPU ISA is not an issue for developers. So x86 or ARM, it's not an issue for AI developers.
No. I think the ISA is kind of irrelevant. The point is, Gracehopper is still two chips, which are connected. Right. Gracehopper is still two chips. They're not packaged together, sharing literally the same memory. So ARM architecture, x86, we're not even going into that, right? I mean, x86 has advantages. We all know those advantages. But the difference is that A is truly co-packaged and then literally attached to the same physical memory. Whereas, as Brad mentioned, okay, they put two chips on one big module, it's still two chips.
So is Gracehopper really appropriate name because the data has to hop from one chip to the other?
Yeah, maybe that's what they came up with.
Maybe, yeah.
Thank you so much.
So AMD is considering the main multi-vendor as part of HBM. So what I want to ask is that how about the perspective of foundry? Is that AMD chips will be made in multiple foundries such as Samsung and TSMC, or is there a main vendor for the manufacturing part?
Yeah, I was gonna say, today, our MI300 is made at TSMC.
Oh, okay.
I should point out, they do the chip wafer manufacturing and the packaging.
Oh, manufacturing. So today is the TSMC made the MI300, but do you have a plan for the multi-vendor?
We're not making any announcements or comments on that.
So hi, I understand that the XCDs and CCDs on the MI300X are manufactured at 5 nm and the IO dies at 6 nm. So I'm just trying to understand from a layman's point of view, what was the technical rationale behind the decision to manufacture the IO dies at 6 nm and not say, keep it to the same 5 nm as the XCDs and the CCDs?
Yeah, we're putting the best technology to the best use case. The IO die is largely just that IO, and the 6 nanometer is better suited and had the correct PHYs to talk to the rest of the world, and so it was a very natural fit for the 6 nanometer process. All the compute and the intense computation, of course, is taking place on the XCD and the CCD, so we put that into the most advanced node to get the best performance on the computational pieces.
I've got one final question. So we saw that, we know that AMD and Hugging Face obviously work very closely together. And Microsoft, they're OpenAI's partner, but they've been your partner for a long time as well. And you must have instances of your AI being deployed on the various cloud services. Which of the partners are really marketing the fact that they're powered by AMD technology? Can you remind us? They make a big deal about it because they're proud of it.
You're talking about GPU specifically, or
about AI capabilities? And who's going to come out? Presumably Hugging Face is going to start using MI300X processors straight away, as soon as they can get their hands on it, if they haven't already got it, to generate all those answers to all those questions that people are now voraciously typing into the ChatGPT.
I think the answer to your question is the partners that are going to be public and forward on their use of 300X are the partners you saw today. So that would be Oracle, Azure, and Meta. I can remind you that Hugging Face did join us in June and announced their excitement to partner with us in June on making, as Vamsi has cited, 60,000 of their models are running on our platform, and that's the outcome of that partnership. And those are the announcements up to date, unless I've missed anything else.
So those are the big guys.
Oh, you can do
and then
that.
there's the tier. There's the next tier of vendors, smaller vendors, right? We announced, I think, half a dozen of those partners that we're excited to be working with as well. So I think it's a pretty, we have a pretty. That is our cloud motion that we're announcing right now, and then we of course have all of our OEM partners that we announced as well.
Are there any closing comments on the announcement that was, I think, yesterday about the 50 vendors, of which AMD is one, working together on AI?
All right. That's the IBM one. Do you have that one? I have that phone.
So obviously, we partnered with that alliance. It's very early days in terms of, all the things that we would do together on that. So stay tuned for that.
Sure. Thank you.
Does AMD have any plans on quantum computing? Sorry, was that quantum computing?
We have not.
That's not what we heard.
Yeah,
we have not.
We always look at forward-looking technologies, so there's always research groups that are investigating that, but nothing today to share.
Maybe only the Infinity gloves for the Infinity fabric are the only connection to the quantum realm, right?
Okay, sorry.
Yeah, one more.
From the Digitimes. Yeah. TSMC says the expense of SOIC, advanced packaging, has been rumored to have problems with the production process from Taoyuan Longtan machine. Will it affect the MI300 shipment progress?
There's a specific vendor that's rumored to be having a problem.
Yeah. No comment.
Okay, got it.
Thank you.
All right. Well, thank you, everybody. Thank you, Vamsi, Brad, and Andrew. And if you have any follow-up questions, you can, follow up with your regional PR managers, and they'll get it to us, and we'll get an answer for you. So thank you, everybody.
Thank you.